Now we're going to do a bit of an application problem to see how we might apply this into the real world. So I wrote a problem here. An engineer wants to build a rectangular base to a house. The base's length is x plus 2 feet and the width is 3x minus 4 feet. What is the area? Now first, let's give some life to this problem. Let's call the engineer Bob. And what he's doing is he's building a base. And this base is going to be a rectangle. So let's draw a diagram for that. Now we know that the length of one side is x plus 2 feet. And then the width would be 3x minus 4. Now, the thing that might throw you off is the variables here. If you just have the length is 2 and the width is 3, or rather the other way around, the length is 3 and the width is 2, you would just be doing 2 times 3, which is 6. Now in this case, we would be doing or using the formula A equals length times width. Now, the length here is just 3x minus 4. Now, it actually doesn't quite matter which one you choose because multiplying them doesn't matter which order you do. And the width is just x plus 2. I know, it looks very similar to a problem that we did before. So we're going to be doing FOIL, and I hope you'll be able to do this without me having to draw the arrows each time. So we would just have the first 3x times x, and you add that to 3x times 2, outer, and then we add that to negative 4 times x, which is inner, and then we add that to negative 4 times 2. Let me just skip this first. Okay. And then we're eventually going to get that 3x squared plus 6x minus 4x minus 8 is the fully expanded form we're actually multiplying through. And then combining like terms, we're gonna get this. But notice, since it's a word problem, we have to include units. And because we're measuring area, it has to be in square feet. Because we're given the length and the width in feet, this would have to be in square feet. And that's our answer. Now, if you see something like a common problem a textbook might give you is x minus 3 squared. Now, this is not in the form we usually see it when we do a FOIL problem. But I just want to remind you, anything, for example, a squared, anything squared is just itself multiplied twice. So this would just be x minus 3 times x minus 3. And you can just apply FOIL here. And I'm sure that it won't be that hard. So this is equal to x squared, the first, the outer, minus 3x, the inner, minus 3x, and then the last, which would just be negative 3 times negative 3. And of course, if your algebra is good, we're eventually going to get that this is equal to x squared minus 6x plus 9. Right? That wasn't that bad. But as I've been hinting at, we're going to get even more complicated. So here you have 2x minus 1 times x plus 3 times x minus 6. Oh no, we don't have 2 binomials. We have 3 binomials. Now you're probably a bit scared. But we'll proceed in how you do this with regular arithmetic. For example, if I have 2 times 3 times 6, what do you do first? Well, you could go about multiplying the first 2 together, 2 times 3, that's just equal to 6. And you just do 6 times 6, which is equal to 36. That is exactly what we're going to do in this problem. So you can see how arithmetic and algebra, they're not that different. so first we're going to do, I'm going to write this in brackets. We're going to first do this. And so we're going to be multiplying it 2x by x, which is the first. I'm going to need more space. And then we're going to multiply the outer 2x times 3. And then we're going to multiply the inner, which will just be minus x. And then we're going to multiply the last, which is just -1 times 3, which is just subtracting 3. And then do not forget our x minus 6 here. Don't leave them out. And you're going to simplify what we have in the brackets. So hopefully you know how to do this. 2 times 3 is 6, so we have 6x minus x. That's equal to 5x. And we subtract it. Now, we cannot use full here because we have a trinomial, but I advise you to use the candy giving metaphor that I taught you. We're going to go through each person on the left, or in this case it's a term, but we're going to go through each term here, and then we're going to give candy to each of the things in here, x minus 6. So let's first start with 2x squared. So for example, we're going to make 2x squared give candy to x, and we make 2x squared give a candy to -6. Okay, so this will just be 2x squared times x minus 6 times 2x squared. Now we're going to add that, and we're going to give more candy. I'm just going to get rid of these lines. Now we're going to move on to 5x. 5x, he's going to give candy to x, and he's going to give one candy to -6. And that's just going to be 5x times x, and then plus 5x. Oops, this plus doesn't want 5x. -6. And lastly, we're going to do 3. -3 rather. And we're going to add -3 times x, and then -3 times -6. So that's just going to be minus 3x plus -3 times -6. Now that's a lot to work out, and I'm going to give myself more space. Okay, continuing. We have 2x squared times x. That is just 2x cubed. Then we have -6 times 2x squared. 6 times 2 is 12, so we're just going to have minus 12x squared. And then we have 5x times x. X times x is just x squared, and then 5 times x squared is just 5x squared. And then we're going to have 5x times -6, which is just minus 30x. And then we're going to have minus 3x, and then -3 times -6 is just 18. That is a lot to handle for one problem, but as long as everything is organized and you have everything set up, then it should be no problem. So notice that we can combine like terms. Not only can we combine the coefficients of x squared, we can also combine the coefficients of x. So final answer is going to be 2x cubed, and then -12 plus 5 is just -7. We'll have -7 squared. I don't know why that's blue. Editors, please cut that out. Please cut that out. And then we're going to have -3x minus 3x, which is just -33x. And finally we add 18. Alright, this is our final answer. Now, if you're able to do this problem, then you'd be able to solve any problem that has to involve some level of polynomial expansion. As long as you have the candy-giving principle in mind, then everything will go well. Now, obviously, there are many things that I've been alluding to, for example, the x minus 3 squared, where FOIL gives us actually a property of perfect square trinomials. However, that's something that will probably be covered in a future lecture, and I'm just going to leave this as a cliffhanger. Thank you very much for listening to my lecture, and I hope that you learned something new today.